Hey again, math artists. So now that we've learned how to do horizontal and vertical lines, let's talk about lines that are not horizontal and vertical. And you'll see that I've added just a little bit to my picture. I've added some variables or letters to just kind of act as like a marking place, and that's so that I can kind of keep track of which lines I've already written equations for and the like. So for example, I just kind of labeled the endpoints here as A, B, and then you'll notice on my graphic organizer next to that equation and next to those constraints, I also put an A, B, just because it makes it a little bit easier to keep track of which lines I'm talking about. I labeled this one as CD. You can see where the equation for that one is on there, CD, and so on and so forth, so that I can just keep track a little bit more easily of what I've done already. So I'm going to highlight the ones I've already done, the horizontal and the vertical. And now let's talk about what we do if we have a line that is not horizontal or vertical. So for example, I'm going to change my highlighter color here. Let's talk about this line right here. So that line is not horizontal or vertical. And so now we're going to use a format of an equation called slope-intercept form that might be familiar to you. And so far, since I've used up all the way to letter H, I'm going to call this line, I'm going to call this little endpoint here I. That represents just this little side of the line right here. So this one is now going to be IC, because those are the letters that are on either end of the IC. And to make an equation in slope-intercept form, which I'm going to go ahead and do on my graphic organizer, so this is going to be IC, we need to use the format of the equation y equals mx plus b. If you're in 8th grade or above, this format of the equation might be familiar to you because you might have done this in math class already. So if so, then you know that the m is going to tell us what is the slope of the line. So basically, like, how steep is it? How much does it go up? And how much does it go over? And so I'm going to zoom in on line IC. And I'm going to draw like an imaginary right triangle to help you visualize, like, in math class we call this the rise. So like what the change is between point I and point C. So basically, what's the change in that distance going up? Okay, this is called our rise, and going over, which is called our run. And please excuse me, that is not the straightest of lines that I just drew here. So I can look and see that the rise, so the distance, I'm going to move this out of the way for now, just to make it a little bit easier to see. So the rise is 2 units high, and what we call the run, the like horizontal distance across here, is 1, 2, 3, 4, 5, 6, 7, and 8 units wide. So what you do to express the slope of that line is you take the rise, the vertical change, and you put it over the run in a fraction. So it would be 2 over 8. And this also, we need to assign a direction to it. And so if you look at this, imagine, if you will, like this is our starting point. Okay, we start and we read a graph moving from left to right, moving in this direction. So it starts lower than it ends up, right? Like it's moving up. So that means that the slope is moving in a positive direction. So that means that this slope is also going to be positive. Now we could have a conversation about the fact that this 2 over 8, if you're good and you know your fractions, you know that you could actually simplify this fraction. 2 over 8 does simplify. That's not really the point of this video, and it really works whether you simplify it or not. So for now, if you know how to simplify, great. Go for it. You can simplify it if you want to. I'm just going to type it in using the plain old rise and run for now. So I'm going to go back to my graphic organizer, and I'm going to replace that letter M with the fraction 2 over 8. I can just use the little French slash button on the keyboard and that'll work, and it's a positive 2 over 8, so we don't need anything in front of it. So that tells me the slope of the line, that tells me what direction it's going in, and that tells me how steep it is. And I'm going to get this out of the way. The other thing we need, or the other piece of information we need is, please excuse my text up there. So the other piece of information we need in the equation is the B, and B stands for the y-intercept. Like, where does this line hit the y-axis? And so I'm going to use the line tool to kind of make this line a little bit longer to help me visualize better, and I think this will make sense if you've never heard of a y-intercept before. I'm going to line it up with this line, and I'm going to extend it out like this. Oh my gosh, sorry y'all. I should have turned off my text, but I'm not stopping this video now because I'm already too far into it. So if you imagine that the line like extends out, then it's gonna hit the y-axis at this spot right here, right? That's where it's gonna hit the y-axis. So let me zoom out to see exactly like what number that's gonna be. And so I'll literally just start down here at the origin, right? And then count up, like 1, 2, etc., to see where that ends up. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if that line did go all the way up through the graph, it would hit the y-axis at 13. So that is the number that is going to be replaced here for the y-intercept right here at 13. So let's type that equation into our graphing calculator. So the equation right here, this y equals 2/8x plus 13. So I'm just going to click in the next open spot, and y equals 2 front slash 8. Make sure that, see how my cursor is down here, like in the bottom underneath the fraction? Make sure that when you type the x for the equation, that it's not down there in the bottom. You want to scoot your cursor out so that it's big and out to the side like that, and then plus 13. So let's see what we got here. So we've got our line. It's diagonal, it does go through the right spot, but just like before, it is longer than we need it to be, right? So we got to figure out where we need to cut this line off as well. And you actually have options for how you want to pull that off. So I'm going to go through and delete all this stuff so that it's a little bit easier to see. And I'm going to use, when it's a diagonal line, you can actually use either the x-axis or the y-axis to decide where to cut off the line. I just feel like in this case, like visually for me, it's easier for me to use the y-axis. So that's what I'm going to use. So I basically need to cut off this line. If I use the y-axis as a reference, I need it to go from that height. I need it to be between these two numbers on the y-axis, which are 10 and 12. So just to note, I could have used the x-axis, like I could have lined it up along the x-axis too, like been like, okay, it goes from here to here, but just because it's closer, like the view is like closer to the y-axis, that's why I feel like it made sense to me to look at it up here. So if we're using the y-axis as a reference, because this is the y, right, we want it to go from 10 to 12. So on my graphic organizer, I'm just going to copy the constraint that I used earlier and paste it down here. I'm actually going to go ahead and add the squiggly lines too. I don't know why I didn't think to just do that in advance the last time, because I'm going to have to put it in the calculator anyway. And so we want it to go between 10 and 12. So I'm just going to change those numbers to 10 and 12. Then I'm going to copy them, and I'm going to paste them into the graphing calculator right next to where I did the equation. Oh, looks like the squigglies don't actually paste in there. That's interesting. So I need to actually put the squiggly braces on either side. And so now you can see that I do have my diagonal line that cuts off where I wanted it to. So you guys pause just a second, or pause this video, and I would like you to go back to the sample drawing. And let me get this stuff out of the way to make this a little bit easier to see. Try to make yourself an equation and graph the line right here. I'm gonna, and then restart the video when you're ready to check and see whether or not you did it correctly. All right, real quick, I realized once I zoomed out on my picture, see how I realized I goofed a little bit. Because notice on the graph, once I zoomed out, I saw that my diagonal line didn't quite match up to where it kind of like overlapped a little bit. And that's actually because I goofed. I didn't do a good enough job when I was measuring this. I didn't have it lined up as well as I thought I should have, apparently. And so it actually is going to be, you can see, it should be a little bit higher than 13. And this isn't an exact science, guys. That's why this is kind of like a little experimentation here. So I realized once I actually lined my line up better, that means I need to change my equation to like a little bit higher. So it's like more like 13.3-ish. So that, there we go. Now that matches up like a little bit better. So sorry about that. So again, just in case we weren't a little bit sure. So what I just did there is I realized I just didn't line that up quite right. The y-axis intercept was actually a tiny bit higher than 13. And again, not an exact science. Apologize for that. But, you know, that's kind of, that's part of it. Kind of playing around a little bit. Okay, so now on to the one at hand, which is this green line, which I'm going to label as DJ. We'll use the letter J to represent this spot right here. So first thing I need to do, which I'm assuming you've already done and that you paused the video. Actually, first of all, let me make sure I'm going to label this as DJ. Oh, and I need to change this from earlier. Oops. All right, so we're talking about line segment, I should say, DJ. So first, I'm going to zoom in here. Now I'm going to make my imaginary right triangle as neatly as possible. And my rise is 1, 2, 3, 4, and 5. My run is 1, 2. So the rise goes on top of the run. And because we measure it, or we read it, moving from left to right, that means we read it from here to here, which means it's going down, which means this will be a negative 5/2. So on my graphic organizer, I'm going to make myself an equation, y equals mx plus b. So that slope of negative 5/2 is going to go right here in the place of the slope. And so the y-intercept, once again, I'm going to add a line. I'm going to try to do a better job of lining it up this time, though. So that if this line were going to continue, it would hit right about here, and it would hit the y-axis right here at +2 if it were going to continue going through the axis. So then the line, the y-intercept, the b, is going to be replaced with a 2. And again, I got that because if the line extended going all the way to the y-axis, it would hit right there at 2. And now I need to figure out where I'm going to cut it off. And again, I'm going to use the y-axis for guidance. So I want it to go from between here, if we line it up that way, I want it to go between here and here along the y-axis. So that means I want it to go between 7 and 12. So let's bring that graphic organizer back in here. I'm going to copy this from when I did it earlier and paste it. But I want this one to go from 7 to 12. So I'm going to replace it with a 7. Oh, and I don't need to replace the 12 because that's the same thing. So this is everything I need that I'm just going to copy. And then I'm going to paste it. Hopefully I did it right. I did not try this in advance, folks. This is literally like real live time where I might make a mistake. I'm going to, let me paste it directly in there. What's up with that? Let's try that again. Live TV, folks, here. So copy. Oh, it's not letting me do that for some reason. So y equals, let me drag this over here where I can see my graphic organizer. So it's going to be y equals negative 5/2. Make sure you put the x out there to the side, plus 2. And then my constraints. And wait for it. Let's see if we did it right. Oh, yep. There's our line that is going like that. So our little drawing is starting to come together. So what I would love for you to do now at this point, now that you know how to make horizontal, vertical, and diagonal lines and how to use the constraints, what would be great for practice is if you would take the rest of the lines in the drawing and try to create this picture yourself. I'm going to provide, you're going to see there is going to be like a little answer key kind of thing that I'm going to provide a link to the graphic organizer so that you can check and see whether or not you're doing it correctly as you're working on it. So far, we got little pieces of the sky coming together, but we still got a lot to do. So if you want to just practice right now, just trying to get him graphed, I would love it if you would do that and then use the answer key to check. If you're ready to just go on to figure out how to do even more shapes, then that will be the next part of the video. So either way, you can, actually, you know what? I changed my mind. I'm actually going to go ahead and the next video, don't try to graph the whole thing yet. I'm going to show you next how to make like an entire figure, kind of like this one. So see how this kind of makes like a closed figure if you look at the way it's all together. So the next video is actually going to be to show you how to do that instead of doing like all the lines necessarily. So you can either practice trying to graph this and make your drawing look like this, or you can move on to the next video and see how to do a closed figure.